Okay, so parabolas. Parabolas are, I would say, the most unique of all of the conic sections, right? Because well, they've got one focus and then a line, this imaginary line, kind of behind or underneath or above the parabola, called the directrix. And so, I mean, we need the least amount of information, I would say, to graph it, but it is kind of the most awkward one because it's something you're familiar with from Algebra 2, but you're familiar with it in a different way. So, as we said in class, we take a very geometric view of the parabola, and geometrically, a parabola is the set of all points that is equidistant from the focus in the directrix, right? And that was that paper folding activity we did to show that when we folded the point onto the line a whole bunch of times, we created a set of points that formed a U-shaped curve and that were equidistant from both the point and the line. So that's the definition geometrically of a parabola. And then we also derived the equation for a parabola, either y squared equals 4px or x squared equals 4py, depending on what kind of parabola you're looking at. Okay, so the x squared equals 4py one is the more traditional parabola, the one you're used to, the one that either opens up or down. The y squared version is the one that's going to either open left or right, because y squared, if we think about it, right, y squared is going to indicate to us that we actually don't have a function, right? So all of our other, many of our other conic sections, or all of them actually, none of them have been functions, right? Think about the vertical line test. A circle and an ellipse certainly aren't passing that, and even the hyperbolas that we've been looking at wouldn't pass the horizontal, the vertical line test. Some of our parabolas will be functions, and some of them won't. The ones that lay on their side will not be. Okay, so this first one is a y squared one, right? And we can tell by looking at the equation, first of all, that it's going to be laying on its side, but second of all, we can also tell which way it's going to open by the sign of this number, of really that 4p number, right? That if that 4p number is positive, we're going to have a right-facing parabola, an opening to the right. If the 4p is negative, we're going to have a left-facing parabola. Okay, so we can see that 4p is positive, right? So 4p here, this guy here, that 12 is equal to the 4p. Right, so 4p here equals 12, which must mean that p is 3. Okay, and we learned in class that the focus, okay, we're centered at the origin for all of these right now. Okay, we haven't translated a parabola yet. So we're centered at the origin. Actually, it's really called a vertex. A vertex is at the origin, not really the center of the parabola. Then P is telling us where the focus is. Right, so the focus is indicated to us by P. Really, it's telling us how far from the vertex the focus is, right? Because when we translate it, it's not going to tell us the coordinates of the vertex. It's going to tell us how far away are we from the vertex. So P is telling us we're 3 units away. And because we know we're going to be opening to the right, we know that the focus is going to be out here. Right, because the focus is kind of inside the U, and the directrix is on the other side of the parabola, right? It doesn't cross through the parabola. So my directrix then is going to be a vertical line kind of behind our parabola, and the equation of that line is x equals negative 3. So the focus is the point 3, 0. The directrix is an equation, x equals negative 3. So now find 2 points on the graph directly above and below the focus. Okay, so we can substitute x equals 3, right, because our focus is at x equals 3. So we want to find, well, when x equals 3, what is y? So y squared equals 12 times 3, which is 36, which makes y equal to plus or minus 6. So we're going to have 2 points. We're going to have the point 3, 6, and we're going to have the point 3, negative 6. So 6, negative 6, and then we can draw our parabola. And then if you remember in class, we talked about this special line that goes through the focus and connects 2 points on my parabola. It had a funny name. It's called the latus rectum. It's also known as the focal chord. Okay, it's a little bit of a better name personally. Okay, so it's also known as the focal chord. And we talked about this in class. The length of the focal chord, we can see on this one, it's 6 units up from center, 6 units down, or 6 units up from the focus, 6 units down from the focus. So it's a total length of 12. Well, this 12 here is telling us how long that focal chord is. So you can actually use that information if you have that understanding and you understand that, well, this 4p value is telling us how long that focal chord is. Then you could start at the focus and go in either direction, half of the 4p value, or 2p, in either direction. So that's another, just kind of a shortcut to drawing a parabola. Or you could do the substitution. It's up to you. Okay, next example here. You notice we have a negative 20y. So this is and it's an x squared situation. So this is going to be a parabola that opens down. So it's always good to just kind of take note of that so that when you actually go to draw your parabola, you kind of have a good idea of where it's going to be. Right, so we know our vertex is at the origin because we have not translated any parabolas yet. That's coming soon. Okay, so to find p, so again 4p is negative 20 in this case, which makes p negative 5. So our focus must be negative 5, 0. Again, I'm going to reiterate, I'm sorry, not negative 0, negative 5. Right, because we're vertical this time. So 0, negative 5. I'm going to reiterate that p-value tells us how far we are from the vertex. It doesn't necessarily give us a coordinate. When our vertex is at the origin, it is also giving us a coordinate. So how far we are from the vertex, we're negative 5. So that's down here. And so our directrix must be the horizontal line at 5. So that equation is y equals 5. Okay, so 2 points on the graph directly left and right of the focus. So we have two choices here. One, we can substitute in negative 5 for y, right? So we could do that. So if I substitute negative 5 for y, I get negative 20 times negative 5 is 100. So that makes x plus or minus 10. Okay, so I can go to the left. I can go to negative 10. Again, poor planning here. Oops, poor planning. I don't have enough room on my coordinate plane. And to the right 10. And then I could draw my parabola. But if you're comfortable with the shortcut and understanding this focal chord, right, that this focal chord has a length of 4p, right, so this length is 4p, in this case 20, then you can simply just start at the focus and count 10 in either direction to get your 2 points. So that'll become actually a nice shortcut when we do translate these parabolas off center, right, off of the origin, because then you don't have to worry about making calculation mistakes when it's not as easy as just like a plus or minus situation. All right, so this is just an example where we can work backwards. Okay, standard form of the equation of a parabola with focus 8, 0, directrix x equals negative 8. So helpful to draw, just so that you know what this is looking like. Your focus is here. Your directrix is here. X equals is a vertical line. So even though we're not told the center is at the origin, we're going to assume that, partly because that's all we've done so far, but also partly we don't have to make that assumption. We know that the vertex is directly in between my directrix and my focus, right? So I know my vertex is going to be here. Because the directrix is to the left, that must mean I have a right-facing parabola. This is my focus here. A right-facing parabola. So I'm going to have a positive situation, and it's also on its side. So it must be a y squared equals something positive times x. And what is that positive value? Well, 4p. 4p must be 32 in this situation, because again, p is this distance, right? P is the distance from the vertex to the focus. So if p is 8, then 4p must be 32, so my equation is y squared equals 32x. Okay, there are a lot of applications of parabolas. There's a lot of light sources are often parabolic in shape. Bridges are often parabolic in shape. So we're going to look at just a couple of different applications. This one is a flashlight using a parabolic reflecting mirror and a light source, as shown in the diagram. The casting has a diameter of 4 inches and a depth of 2 inches. What's the equation of the parabola used to shape the mirror? At what point should the light source be placed relative to the mirror's vertex? Okay, whenever they ask that at what point, they're looking for the focus here. Okay, so this is the focus. But we can't find the focus until we have an equation. Okay, so we have to kind of look at what information is given. This is a little tricky because there's not anything super direct given. My recommendation would be to always, when you're dealing with an application, always place the vertex at the origin. So we have a parabola with its vertex at the origin. If it was an ellipse, place the center at the origin. That's how we, when we did the ellipse applications, the recommendation was always place the center at the origin. Make it easy on yourself. You don't need to make it more difficult than it is. Okay? And the important thing to see here, and this is kind of hard to see, right, is in order to keep it, this is going to be an x squared equals 4py situation, right? Because we're upward facing, right? So it's an x squared. And we really don't have any information. We don't have p. We don't really seem to have a y or an x, but we do have, we can find a y and an x, right? You have 2 points on this parabola, and it's up to you which one you choose. I would highly recommend choosing the positive one so you don't make any negative mistakes. Okay, but this point here, based on the information we're given, this is the point 2, 2. Over here is the point negative 2, 2, right? Think about that for a second. If this distance is 4 inches, and we put the vertex at 0, 0, that must mean I go 2 this way, 2 in this direction and 2 in this direction, and I know that I'm 2 inches high. So I have the point 2, 2, or the point negative 2, 2. Again, I'm going to use the positive point just because I don't want to deal with any negatives and make any mistakes. So if I substitute 2, 2 into the equation, I get 2 squared equals 4 times p times 2. So that's 4 equals 8p, which means p is a half. Okay. So my equation, right, the first thing says what's the equation of the parabola used to shape the mirror? My equation is x squared equals 4 times a half, which is 2y. And then at what point should the light source be placed relative to the mirror's vertex? Well, keep in mind that this p-value is telling us how far from the vertex is the focus. Right, so if p is a half, then my focus must be at 0, 1/2. Right, so my focus is like up here somewhere. And that's where the light source should be placed. Okay, let's look at one more example. Okay, one last example. The parabolic arch shown in the figure is 50 feet above the water at the center and 200 feet wide at the base. Will a boat that is 30 feet tall clear the arch 30 feet from the center? All right, so let's think about what an equation for this is going to look like. And so we have a couple of choices. We could make a substitution. Choose one of our points and make a substitution, or we could, we would have to assume if we're not sure though if this is the focus or not, and maybe this is the latus rectum. So we're not really sure. So you're better off choosing a point. Either one of the endpoints here, the -100, -50, or the 100, -50, because if we choose 0, -50, it's not going to help us solve for p, because we're going to end up with a 0 situation. So I will choose the one with the +100, right? And we know that this is an x squared equals 4py situation because it's an up and down parabola, and it's upside down, so we can kind of make the conclusion that our 4p value overall is going to be negative. So at least we kind of know that going in, so we'll be able to identify if we make any mistakes. Okay, when x is 100, so if I plug in 100 squared, y is -50. Right, so that means 100 squared is 10,000 equals -200p. So that gives me p of -50. So coincidentally, this point here that I said we might be able to assume is our focus, it is indeed our focus. Okay, which does mean that this is our focal chord. So we can use that to find the 4p value, or we can, just multiply this by 4 and get that our equation is x squared equals -200y. Okay, so here's our equation. The question we need to answer is, will a boat that's 30 feet tall clear the arch 30 feet from the center? So again, we're looking kind of like at this point here. We basically want to know how tall is the arch, right? How tall is the arch 30 feet from the center? Okay, so if I substitute 30 in for x, 30 squared equals -200y. So that's going to give me 900 equals -200y. So y is -4.5. So now we have to interpret what that means. Okay, if y is -4.5, let's think about that. That means that y, when we go across 30, right, when x moves up 30, y has only decreased by 4.5 feet. Okay, so it's only decreased by 4.5 feet. At the highest point, it was 50 feet, right? It's decreased by 4.5 feet. So this space here is essentially 50 minus 4.5, right? So 45.5 feet. So there's plenty of room for that boat that is 30 feet tall to clear it, right? So again, this -4.5 is telling us that because our center, our vertex at the origin, our origin is up here at the top, right? We've gone down 4.5 feet from the topmost point, and the topmost point is 50 feet basically above the water, right? So the topmost point, once has moved down 4.5 feet, that gives us about 45.5 feet of clearance. So a boat that's 30 feet tall will clear this without too much of a problem.